How are we doing today, guys? Today we're going to be learning about measuring using a micrometer. We'll be measuring things in fractions of inches using decimals. Like, I'm sure you all know what this device is, a ruler. This I'm going to leave to your woodshop teacher to teach you, because in auto mechanics, when we're measuring like rotors, we're going to be using a tool called like this. It's called an outside micrometer. All right. This is like a 0 to 1 inch, so you can't measure anything over 1 inch, and this is a 1 inch to 2 inch micrometer. And then we have more of a modern one. We have a digital one, but what's great about this one, even though the cap fell off, is we have outside diameter, we can measure inside diameter, and we can measure depth of an object, all right? Now this is what most people use now, but I'm going to start off by teaching you the old school mechanical micrometer. Okay guys, welcome back. And what you are looking at is a micrometer. So this is a 0 to 1 inch. So right now there is 0 gap in this piece of metal. So each one of these lines is equal to 1/1000th. So that would be 1/1000th of an inch opening. You can't even see that there's a gap there right now. I can't even fit a piece of paper or human hair in between it. That is 1/1000th of an inch. You can tell now that I'm opening it. Now you might be able to see the gap. But I had it at exactly no gap at 0, 0 on 0. All right? So I'm trying to teach you how to read this. So the first number I'm going to come to is I'm going to open it up to 5/1000ths. There's a very small gap. What that looks like on paper with math would be 0.005. Now when we go to cut rotors, that's about how much material I remove every time I make a pass on the rotor. All right, so let's move to the next number. So we're going to go to 0.25. So I'm back at 0 again, but what we have is one full line. So if you look at the sheet, I have moved this piece right to this line. When 0 is lined up with this very first line, that is 0.25. Now this is easy to remember if you think about money. Each one of these lines is equal to 1/4, a quarter, you know, that you have it in your pocket. So we have 25 cents, 50 cents, 75 cents, $1. Okay? So right now I have it at 0.025. Now I'm going to open it up another 25/1000ths. So I got 5. So that would be 25. That 5 would be 30. 35. 40. 45. Now we're back to 0. 50. Now you can see there's a gap. That's a 50,000th. So what that would look like in a decimal would be 0.050. All right? Very small gap in my tool. So now the next number we're going to do is we're going to go to 75. I'm going to go, now we are at 50, 55, 56. See how there's a little 6 there? That would be 56. 60, 65, 70, back to 0 again, 75. And now there's 3 big lines. So what we're looking at is that we are right there. We have 3 lines. We have 25, 50, and then 75. So 0.075. All right. So the next number we have would be 1. So I was at 75. Let me go back to 75. 75, 80, 85, 90, 95, 100. So if we had, say, a piece of metal we were measuring, and that would be 0.100. So that would look like, on a decimal, would be 0.100. So if we look at this image right here, and we start counting 25, 50, 75, 1. Let me write that down. So we know we're over 1 because the 1 is showing. Let's see if we can write that. So I got my first decimal. Ah, got it wrong. Sorry, it's hard to draw upside down and backwards. So I got my decimal, and we are definitely at 1. So now we got to figure what else we're at. We're at 25, 50, and then we have this gap, and it's all the way up to 0, so that must be 75. So we are at 175. That's what letter A is doing here. Now, let's try to get a little bit more complicated. So now we got this number, letter B example. So we're starting at 0. We know we got 5, because that's the last number we see. So we are at 0.5. I'm trying to write upside down. I don't know if I can do it properly. But let's count what we got. We got 25, 50, 75, and then we're almost all the way back to 0, but we're not quite there. So that would be 5, 9, 9. So almost 0.6. So 5, 9, 9. Now I understand you guys probably understand decimal. What I'm going to do right now is I'm going to measure the thickness of this pencil. So I'm going to put this tool in here and see how close we can get accurate compared to my digital one, because the digital one is going to make sense. It makes it easy for you to read. So what I have showing is I have the number 2. So we're definitely going to be at 2. And I have 1, 2. So I'm at 50. 0.25 and then 20. So 0.25, 20, so that is 0.257. Nope, sorry. I got to write it down. 2.5, 2.6, 2.7. 2.70, that's what we're at. So let me write that in a decimal real quick. 0.2 No, 70. So what we had here on our pencil, the measurement was 2.270. Now let's do it with this one. We'll turn it on, make sure it's at 0. So right now we have no gap. And we will open it up. We will put our pencil in and see how close we got. 0.270. So that's the thickness of our pencil. Maybe even a little smaller because I squeezed it really hard. 2.70. Kind of get it? So that thickness, these two thicknesses are exactly the same. So that's what the thickness of a pencil is. Now we're going to have to measure rotors. So what I have here is 2 rotors, one that I machined the other day, one that I'm about to machine, and the rotors have what's called a minimum thickness. So I have to still look up the spec. But what you would do is you would go to a rotor. Now these rotors are thinner than 1 inch. And I open my tool. Now I don't want to like use this as a clamp and really go down on it. I want to get it down that it's just snug. Now the reading I have on this is 9. I see the number 9. And I see one big line, which is 25. And now I'm at 11. So that would be, another 10 would be 60. So I'm at 961. All right? Now let's see what my digital says. Because I have a 9. I see one full line, 25. 25 and 10. Oh, maybe I got my numbers wrong. Let me try this again. So I got 9 and 25. Then I got another 10 now, which would be 35. So I think it's going to be 0.936. Because 10 on 25 is 35 and one more is 36. I think it's going to be 936. So I'm starting off with 0. I opened up the gap of my tool. We'll see what we got. Pretty close. So I got 9. I don't know if we could see it. 937. So between the digital tool and the electric tool, we're like 1 digit off. All right? So now what we're going to do is we're going to measure this one and then cut it and see how much we take off. So I'm going to take my digital tool, put it on here, and we got 0.992. 0.993. Sorry, now we're going to put it on the machine and cut it.